Alright, welcome back. This is part 2 of the video we did last time where we were making a small piezoelectric hydrophone preamplifier board. After doing it and stopping the video, I came back and noticed that there were a couple mistakes, maybe ones you noticed. And that's good practice too. So we're going to go through an example of sort of when you realize you screwed up the schematic, how to go back and make changes and change those in the board. We're also going to do a different way of doing fill. And we're going to look at sort of how to manage pores through the manager that Altium has that's dedicated just for that. So I'm going to start off by sort of showing what went wrong with the schematic. So this basic preamplifier was a two-stage preamplifier. We have a gain of 10 non-inverting amplifier here. We were supposed to have a gain of 10 non-inverting amplifier here as well, but if you look, I actually made this an inverting amplifier here. So we're going to have to change this to, we're going to have to sort of redo this schematic to properly make this a non-inverting amplifier stage. So to do that, we're just going to break this wire. Just select it, hit the delete key. We're going to select all of this, and we got to give it a little bit of, we got to, oops. Move this around a little bit, and we're taking a little more than we want to here, but that's okay. Okay. Oops. Okay. Just fumble around here and move a few more things. Okay, so to make this a non-inverting amplifier, it has to be wired like that and wired like that. Now there are some design options here. So as we talked about last time, and this is not Altium theory, this is just schematic theory, the reasons we usually don't like to do a non-inverting amplifier for these sort of bandpass high gain preamplifiers is because the non-inverting amplifier will never attenuate that input signal. So it can't actually attenuate the signal outside of the pass band. But because our gain, in this case we have a two-stage gain where the total gain is 100, so that's a 40 dB gain. Because we have a gain that's that high, the fact that we are amplifying the passband that much essentially does the same thing in terms of getting several dB of separation between our passband and our non-passband. So, and the advantage here of using in the last video I sort of said there's two reasons we like the non-inverting amplifier, and then I only gave one reason. So the second reason is that typically the noise for these amplifiers is going to be less. You're going to have less noise using the non-inverting amplifier configuration. Not by a lot, but by a little bit. It's a sum of a benefit, some benefit to have it be a non-inverting configuration. But of course the big thing is we get to have that input to the positive terminal of a JFET op-amp, which is a very high input impedance. Doesn't matter so much for the second stage, but it does matter for the first stage. So we changed our circuit here, and we can go back now and we can just do design, update PCB documents. We didn't have to re-annotate anything. And you'll see immediately, because we changed the way those signals are connected, a lot of these wires that we made now are causing a problem, right? Because things are connected to signals they shouldn't be as a result of the rewiring. So we're going to have to go back and clean this up. And generally the first thing we want to do is, if we had pores, we want to just get these pores out of the way. Of course, the pore immediately shows up as an error. You sort of see, this Altium throws an error, these little green X's here. And so usually just for routing, I just want to get the pores out of the way. So there's a couple things we can do. So one thing we can just delete the pores. But the best thing to do is go to the Polygon Pores Manager. So go to Tools, Polygon Pores, Polygon Manager. We actually could just right now just shelve these two polygons if we wanted to, but I want to show you the Polygon Manager. So the Polygon Manager is a tool that shows you all of the polygon pores that you use. This is beneficial not only for just sort of seeing what's there, because it can be tough to sort of see where they are once they're on the board. So you can clearly see sort of the structure of each one of these pores. But the other thing that you can do with this is you can order the order of these pores. So what's the order? What's the pore order? So for instance, if you have two polygon pores that overlap each other, basically the one you pour first is going to totally fill the area. It's going to totally fill its area without violating the rules. And then the one you pour second is going to fill its area. So if they had overlapped and pore one had filled up part of the area, then pore two that comes after wouldn't fill in any of that area that was filled in by pore one. So it's just sort of a way to give priority when you have pores that kind of overlap each other. So for right now, we can shelve these if we want. We can shelve these by clicking this. And what that's just going to do is it's going to say the pore still exists, but it's not activated. So we haven't deleted anything. We haven't lost any information. We're just saying, let's, in terms of visualizing this and actually showing the copper for this pore, let's take a step back. Let's not do that stage yet so that we can work on the wiring. So if we do that, and again, we could have shelved that. We could have gone Tools, Polygon Pore, Shelve right here. Or we can do it through the Polygon Manager. So now we can look in here and see what our actual wiring errors are. So yeah, it looks like we have. So we're going to want to get rid of this violation now. I don't know why that guy is still going to fit. Looks like we still got a little piece of copper in here. And I don't know why it's still throwing a fit. Here we go. I got a little track there. Okay, and the reason that was throwing an error is because that track was defined as net C1_2, or actually I think that track was defined as the microphone negative input. And no, sorry, it would have been defined as net C1_2. And because that track was defined as having that signal, even though we deleted the segment and the segments were separated, that little piece there was still saying my signal for my little piece of wire is net C1_2. And that conflicts with this pad, which is mic negative. So, okay, so let's go back and sort of see what to do here. Okay, so we got to get, so net C12 has got to get down to here, and mic negative has got to get to here. So unfortunately, this is something that we actually want to keep this signal close, right? We don't want to have extra length on these, because the signal, this mic positive and mic negative signal, is a very sensitive, it's high impedance, it's a very small voltage signal, very small current. It's very susceptible to noise, so we want to keep this as short as possible. I'm at the point now where I would probably want to kind of reroute this side of the board, and the reason for that is my whole reason for initially putting these things where they were was so that we could keep our signals close to mic negative and mic positive. If this signal is now, yeah, if this is, oh, you know what? No, that's, mic negative is our ground. Yeah, so actually I think we're okay because we're going to have that ground pore there. So I think that's going to be just fine. Yeah, that should be just fine. I take it all back. But let's say we wanted to rip something up. I still want to rip something up. So if we want to reroute something, and I'll just pick an example, it's fairly straightforward. I'll just pick this one right here. Let's say we want to reroute this guy. You know, one thing we could do, and one thing I see a lot of students doing, is they just take these segments and delete them. Right? That's one thing. There's other stuff you can do. So there's other options. Usually people get pretty good with them with hotkeys. So one thing you can do is, if you go to route, you can unroute, net, so you can unroute a connection, a net, a component, a room. We haven't talked about rooms, but rooms are basically just regions that define where certain components should be. So you have lots of options for unrouting. You can unroute all too. If you do unroute all, and sometimes this is called rip up. In other software, this is called rip up. Unroute all gets rid of all of that, and then of course we're going to undo that. If we want to unroute a net, we can set my grid where it doesn't throw fit. Oh, see what that did is that just took everything that had that name, that sig out. It just unrouted that. Uh-oh. Oops, still in the unroute tool. Okay, now if we go tools, oops, route, unroute, connection. Oh, now that just unrouted the connection between these two components. So it didn't unroute the whole net, just that connection that I clicked. That connected this pin to this pad was what got taken out. Escape, Control Z to undo that. Go back to route, unroute, component, and then if I click, for instance, this U1, that's going to wipe out pretty much everything. But you see, you click on a component and it will then remove all the routing to and from that component. So maybe a better example would be here. Like let's unroute this guy. See, so all the signals to and from this C2 component now got removed. Escape to exit the tool, Control Z to undo. Okay, so those are options for unrouting, and it really helps when you have to change something. Especially if you remove a part or add a part or swap out a part. A lot of times if you swap out a part, you can do a part swap, but it leaves all of your original routing, which is kind of a mess. So sometimes it's good to just get it all out and redo it. So this, just now that I remember that this mic negative was our ground, I'm not going to worry too much about this. So now we just have to route this guy down to here. So if we want to do this, we can. I'll probably pull this back, and then make sure top layer is selected. Route. Oh, and I had a wonky setting here apparently. So shift spacebar to change my routing style. Okay, so now, hopefully we'll see this ground, which I probably should have never used the label mic negative. So hopefully we'll see this ground sort of repour when we do our repours. I want to show a different way to do repours, and this is very common if you want to pour over an entire board. So if you want to pour over an entire board, it's sometimes good to just set the board outline first, to set the board shape, and then use the board shape for your polygon pour. So let's do a board shape. I want to make this a circle. I want to make this a perfect circle here. So how do we do that? One of the big issues with Altium is Altium doesn't. You can define a board shape and it'll do it in the software, but Altium doesn't do a good job of helping you export that board outline as a Gerber. So Altium just basically doesn't do it, which means almost always, usually what I do is define your outline using some unused mechanical layer, then define the board shape based on that layer, based on the tracks and radius sweeps or arcs, the tracks and arcs from that layer to define your board outline. And so rather than sort of defining the outline and then using that to make something that represents the outline in a Gerber, we're going to make the outline with something that we can represent in a Gerber and then use that to define the board outline. So let's do a perfectly circular outline here. So I'm just going to use Mechanical 3 because I know I haven't used it. Some people use Mechanical 3. I would avoid using Mechanical 1, Mechanical 5, Mechanical 13. Those seem to be used by others for things. You basically just want to make sure you're using a mechanical layer that's not used by anything else. You can do the keep out too. So the keep out, sometimes people use the keep out for other stuff too. you can use the keep out layer. So you can use keep out, and then we can do place full circle here. And somehow I didn't. Somehow it no longer became keep out. Well, that's fine. Okay, so not totally centered. So we'll do this. We'll use this circle as our board outline here. That looks pretty good. Okay. So we can, if we select this, we can change the layer now to whatever we want. Apparently keep out's not one. Whatever, that's fine. Altium's got some weird rules. So we'll just make this, yeah, we'll make sure it's mechanical 3. No net. Looks good. So now once we have this and we know this is what we're going to use for our board outline, one thing we want to be careful of is if our board outline is mechanical 3, we want to make sure that we, when we export our Gerbers, that we say export GM3, export the mechanical 3 layer, and then we want to make sure that before we send it to the fab, we change the name of that. It's gonna output a Gerber that's project name .gm3. We want to be sure to change that to .gko or whatever extension the fab is expecting for an outline file. We're just going to change the name to that. It's just a Gerber. All Gerbers are just Gerbers. Once you change the extension, they don't know what layer it's supposed to be. So, okay, so let's make a board from this shape. So we can select this shape, and then we can do design board shape defined from selected objects. So what that did is that just, you can see it just changed the actual board shape to completely fill this mechanical 3 outline here, which is great. And if we hit 3 to show in 3D view, we can see, of course, the 3D view reflects that change. So we will later do we'll do a fill for this guy now. So for the fill, we are going to so we're going to do a pour again, just like we had before. We're going to do a pour on the top and the bottom with ground layer, with a ground pour. But what we're going to do is we're going to start that by going into the, in this case, we're going to start it by going into the, previously we had done, place polygon pour, and that will have you set the parameters for the pour and then sort of choose some points along the way. But now we're going to go into we're going to do it through the Polygon Manager. So we're going to go to the Polygon Manager, and in this case, we want this pour to just completely go to the outer edges of this board shape. So we're going to go create new polygon from board outline. And then now it's going to already have populated exactly what we need to, exactly what shape that board outline is, and it's going to automatically have those as the outline vertices for these, rather than having us specify the pour and then go back and choose the points that define the area of it. It choose the area based on the outline, and then it just says what do you want it to be. So in this case, it's going to be a ground. Top layer is fine. Connect to net. Our ground was that mic negative. Pour over all same net polygons. So, and again, this can be if we already have traces that are routed as net negative, ground, whatever. If we want to leave those in place and not have this pour actually touch those, we could just do don't pour over same net objects. Or we could do, if we only want to have it sort of merge with polygons of that same signal, we can just do pour over same net polygons only. Or if we want to have a pour over anything, we can do pour over all same net objects. So that's going to wipe out any traces we had. If our pour comes in contact with a trace that's what we already defined, or at the track we've already defined, it's just going to completely wipe it out. Not wipe it out, but add to it, right? Lower resistance is all better. So this all looks good. So we're going to do that. You'll notice it doesn't show up yet. We still have to click apply. So now it shows up. And now we're going to do that again. We're going to do create polygon from board outline. Once again, we are going to do, so now in this case, we're going to do the bottom layer, ground, connect to net, mic negative, pour over all same net objects, apply. So now, now we've got that pour So we did that entire pour just from the Polygon Pour Manager. We weren't even looking at our board while doing that, but if we go back to the board, we'll see it show up here. So now we can see that pour, and you'll see the pour now extends all the way out to that outer edge of the board. So we're almost done now with this board. We've almost gotten to the point where this is sort of everything we want. But what we can do is I always like to check, and probably we'd want to add a name or a design reference or a date or some other silk screen here. We're not going to do it in this video. I always check the 3D, and if we look at the 3D for this, it looks pretty good. So, looks pretty good here. But one thing you'll notice is, look at these. The vias here are exposed. So the vias, we can see the metal layer for these vias, and that's because these vias are not tinted. And so there's always with vias, we have this option to tent or not tent. And the idea is basically, if we want to plug this via, if we want to cover this via with solder mask, that's called tenting a via. And tenting a via, the advantages to tenting a via are, one, fluid can't flow through that generally. Sometimes after you tent, you still can get a hole with fluid that goes through there. But the biggest advantage is there's no way to get an electrical connection there. So it's shielded basically, that via, and that can happen if you have solder. There's some solder processes where you run the risk of having solder sort of fill this via. You run the risk of having solder bridge between the via and a pad. So if you want to avoid that, if you want to make sure that's avoided, you want to make sure nothing can get in there, and make sure it's electrically isolated, then definitely you want to tent your vias. The benefit of not tenting the via is, one thing is it gives you sort of a cheap test point, so it gives you something you can contact with to get the signal for that. There's other ways to do that. You can actually make a via a formal test point, or just make it bigger and just have a big enough hole at that via location that you can actually put an actual test point in there, or solder it in, or just have a sort of spring fit test point there. So if you want to use it as test point, I usually would recommend that you make it a formal test point. So there's, also sometimes students like to have those exposed, because if you screwed up your design, you can go back, and if you need to sort of just run a little wire to make a connection to a signal, via is one location where you can solder that on. The other option is you can always just take a razor blade and scratch off your solder mask. If you want to just get access to any copper anywhere on here, you can do that. So that's another option, but some people like to leave them open. I generally will tent them. The only time I won't usually is if I want solder to flow through there. For instance, if I'm using a via under a thermal pad and I want the solder to be able to flow through there, or I want to be able to use those vias. Sometimes it's kind of nice if you can get a little bit of solder to flow through them. You can use them as a place to put an iron on to get heat to heat up that entire pad. Usually there's better ways to do that too, but there's some options, right? There's some options for doing that. So we can, so I'm going to show you how to tent these if we want them tented, which I do, especially going back to under the board here. I hate having untented vias underneath a chip. So one thing, I can't even run a jumper here if I wanted to. I could on the back side, I guess, but I hate having it. You can have a little solder bridge underneath here if you're soldering this by hand, or have a little too much when you're doing reflow. You can have a bridge here and you'll never know about it, and it's going to drive you nuts. So I like to tent these. So one thing you can do is you can always click this, hit tab, or double click it. Oops. Yeah. So what am I doing here? Yeah. Yeah, so we can do force tenting, force complete tenting, top and bottom. Sometimes you'll just tent half, sometimes you'll just tent one side, and people like to do that sometimes. A lot of times you'll see people do that for when they have vias for a thermal pad underneath a chip. They'll tent just the back side of it, and that prevents solder from flowing all the way through and making a bubble on the back side. It prevents it from getting sucked in, but it still allows you to have, you still have that, you're going to have that exposed copper on the thermal pad side no matter what. Okay, so we can do that, force tenting, and it doesn't show up, right? You don't really see it there. You don't really see the change when you're viewing your board like this. You will if you select, if you go to the layer, I got way too many layers active here. So if you look at top solder, yeah. So top solder now, this one has a little, this via has a little purple ring around it. This one does not, and that's because the top solder shows all the locations where there is no solder mask. So the location shown on top solder is where there's no mask, which is a little backwards, but whatever. So another thing you can do, if you've got a lot of, say you've got a lot of vias, you did all your routing, you got 80 vias or something like that, you know, select one, right click it, go find similar objects, select all vias, yeah, just apply, so it'll select all of them. And I don't know what I did to change it to have it not select that, but whatever. Once you select all your vias there, you can just do solder mask tenting, top, bottom. And now if we go back to the 3D view, look at that, now it's covered. If you look in here, 3D view, now we have this thing covered with green. If we flip over to the back side of the board, again, both of these are tinted there, so it looks a lot better. Okay, and now I'd say this guy is pretty much ready to go. I mean, again, other than the silk screen and stuff, but that's the process. And again, you know what? It doesn't hurt to one more time. Let's go through and do, well, first of all, let's do a design rule check. And we got silk to solder mask, silk to silk. You know, some people would make sure those are all alleviated. I don't care too much about those errors, so I would consider this okay. If you're working at a company, you'd probably have to formally approve each of the, you know, those errors. It depends on the company. Some companies definitely have a rigorous process of each and every error has to be addressed or commented on or dealt with, and these could be mitigated. All these could be mitigated just by moving, you know, these numberings further away from the actual part. I just don't want to bother with it. It'll be fine. Maybe I can move that R2. That guy was a little close. I agree with that one. So another good thing about tenting these vias is if you do have text that crosses over one of these, if you don't tent this via, that text will be cut off. So the silk screen will not bond to anything except for solder mask. So if you don't have solder mask where a via is, it's gonna cut off the areas of your silk screen. Usually if the via is there, it looks a little bit better. It stays a little bit more. All right, so real quick, let's just do let's save this. Can I save all? There we go. And let's just do a fabrication output. I always like to do as many examples as possible of fabrication output. So Gerber files. I like to do 2.4, top overlay, top paste, top solder. I like to reverse the top paste too. Bottom layer, bottom solder, bottom overlay. Now mechanical 3 was our board outline, so we're going to do mechanical 3. Perfect. Let's go back to the board, file, fabrication outputs, and see drill files. 2 to 4, keep leaving trailing zeros. That doesn't matter. Perfect. Okay. So now we can go into our project folder. And first thing we want to do is that GM3. Oh, didn't mean to do that. So that GM3 will change this guy to a GKO. Okay, and then we'll get those 8 magical files we need. Bottom layer, bottom overlay, bottom silk, board outline, top layer, top overlay, top silk. The top paste file, that's good for us, but the top paste file we're going to use to make a stencil later, but the fab doesn't need that. And then our text, which is our drill file. So, and then we're just going to send these to compressed zip folder. And oh, ready for fab. So we can take this and just upload it to our favorite fab, Osh Park, PCB Way, whatever, and we're good to go. Alrighty, thanks for watching.